Determine the force in members J, K, Jn, and CD. State if the members are in tension or compression. Identify all the zero force members. Before we begin, let's identify the zero force members. So it's going to be IO, KN, LB, HE, GE, MB. All of these are zero force member because they are perpendicular and they are not carrying any load. Now to our problem. To solve this problem, we'll be using method of section. Reason being because we only need 3 member forces. And before we begin, we need to determine our external reaction forces. But because we are using method of section, we only need to determine the reaction force, external reaction force for the side we are solving our problem for. And in this problem, we're going to cut our member in the following manner. And in doing so, I'm going to use left-hand side of the truss to solve this problem. Therefore, we only need to find external reaction force for AY. To do that, we're going to take a moment about the point F. We have two symmetrical external reactions of 2K. Both are counterclockwise. First one is 20 feet away and second is 50 feet away. And then we have AY, which is clockwise, and it's 70 feet away. All equals to 0. All for AY, we get our solution as 2K. Now we can draw the free body diagram of the left-hand side of this truss. It's simply going to be all the way to the point K. And by inspection, we can also say that our AX is 0 because there isn't any other horizontal force acting on this truss. And on the horizontal side, it's going to be all the way till point C. Let's see, external reaction force of 2K. And then we have another member going diagonal till N. And that's our leftmost portion of the truss. And now we can draw the free reaction forces. So we can have force Kj, we're going to have force Nj, we're going to have horizontal force CD. To solve this problem, because we're not using the other part of the reaction or of the truss, you can have imaginary point E, J. I'm going to sum the moments about this point to find our solution for force CD. So it's going to be moment about the point J. Doing so, there isn't going to be any moment arm at force Kj and Jn. We're simply going to have counterclockwise force CD, and it's 20 feet away. Counterclockwise 2K, and it's 15 feet away. And one thing, before we move on to the equilibrium equation, we need to find our angle between NCD and our angle between AMB. To find our angle for NCD, it is simply going to be tan of 20 divided by 15. This gives our angle for NCD as 53.13 degrees. And for angle MAB, it's going to be tan of 20 divided by 35. And it comes up to be 29.74 degrees. Okay, now back to our problem. And finally, we're going to have clockwise AY. And it's 35 feet away from our joint J, all equals to 0. So for force CD, we get a solution as 2K, and this member is in tension. Now let's sum the forces in X direction. We're going to have force CD, which is 2K, horizontal component of Jn and Kj, all equals to 0. Let's simplify this equation. We're going to have 0.6 force Jn, 868 force Kj, equals to negative 2k, and we're going to name this as equation 1. Now let's sum the forces in y direction, because we can't really solve this equation any further without the assistance of our vertical equilibrium equation. So it's going to be ay and external reaction force, they cancel each other out, so we're not going to write, and then we're going to have a vertical component of force kj and jn all equals to 0. Let's solve for force jn. Solve for jn, we get our solution as 0.62 force kj. Now we can plug this equation, which is equation 2, we're going to name it, and into 1. So it's going to be 0.6 times 0.62 force kj plus 0.868 times force kj equals to negative 2k. Solving for kj, we get a solution as 0.43k. Now we're going to plug the value of k into equation 2, and we're going to have force Jn as negative 2.5k. What this means is we assumed our vector in the wrong direction, force Jn. So switching it over gives our solution to be positive, and this also tells us that this member is in, pardon me, it's going to be the other way around, because I just looked, I missed our negative sign for negative 2k in the earlier equation. So this equation is going to be negative. So that means our force kg is negative, and this would make our force Jn to be positive. So that means we assumed our direction for force Jn in the right direction, but our direction for kj is wrong. And that's also going to tell, once we flip our force vector force kj, it's going to be telling us that this member is in compression, and our force member, or our member Jn, is in tension, because this vector is going away from joint N. And with that, we solved our